Okay, in this tutorial I'm going to show you how to integrate, and this is a definite integral in between the limits of 1 and 8. Before you can integrate this though, you have to get it ready for integration, and to get it ready for integration you have to first of all change this surd into an index, and to do that we can rewrite it as the integral between 1 and 8 of x to the power of a third. So when you integrate, you first of all have to increase the power by 1. So when you increase a third by 1, you get 4 thirds. And then you have to divide by the new power. So I'm going to divide by 4 thirds. And now that's in between 1 and 8. To tidy this up a little bit, we can remove this double fraction here by multiplying both the top and the bottom by 3. So you end up with 3x to the power of 4, to the power of 4 over 3, the power of 4 thirds, all over, and then these 3's here will cancel, so you just end up with 4. And again, that's still in between 8 and 1. Now it's possible to do this question without using a calculator, so what I'm going to do is change this now back into a surd. So I can do that by writing 3, now that's going to be the cube root of x to the power of 4 divided by 4. So let's sub the values in now. We'll first of all start off by substituting in the 8. So I've got 3 times the cube root of 8 to the power of 4 divided by 4. And on the other one, it's going to be 3 times the cube root of 1 to the power of 4 divided by 4. Okay, so we're going to try and do this without a calculator. Now, 8 to the power of 4 is a tricky thing to work out. You could work it out, but it's much easier if you first of all did the cube root of 8, and then you elevated that answer to the power of 4. So the cube root of 8 is 2. So it's going to be 3 times 2, and then that's to the power of 4, divided by 4. And then we're going to take away 3 times, well, it doesn't matter how you do this, 1 to the power of 4 is 1, and the cube root of 1 is 1 over 4. Now I've just run out of space on my bit of paper here, so I'm going to go across sideways. So it's going to be 3 times 2 to the power of 4 is 16. Well, 16 divided by 4 is 4, so 3 times 4 is 12. And this one here is going to be take away 3 quarters, so the final answer is going to be 11 and 1 quarter. Okay, so I'll just go through how I got that again. I did, instead of first of all multiplying 3 times 16, I did that there is 16. 16 divided by 4 is 4, and then 4 times 3 is 12, and then I took away the 3 quarters. So there you go, that's how you work out that definite integral. Now I've got another one here that I want to show you. This time it's not a definite integral, it's just a normal integration. But this is a bit trickier though, because you've got to, there's no way you can integrate this yet. You've got to get it ready for integration. So the first thing you do is you split the fraction up into 2 separate fractions. So I've put this part, the x to the power of 4x to the power of a half over 2x, and also I've put 5x to the power of negative 2 over 2x. Again, you still can't differentiate that, so you still can't integrate that until you have combined these x's together. So this is x to the power of 1, and when you divide by you divide indexes with the same base, you do a half take away 1, which will give you x to the power of minus a half. 4 divided by 2 is just 2. And over here, we can't do 5 divided by 2, we'll just leave it like that. But again, we've got 1 here, x to the power of negative 2. We take away the 1, is going to give us x to the power of negative 3. So again, we're still not integrated yet, but now it is ready to integrate. So we can increase the powers by 1. So if I increase negative a half by 1, I get a half. and I'm going to divide by my new power, but remember there's still the 2 there at the front. On the other one, I've still got the 5 over 2 at the front, but then I'm going to increase the power by 1, so it goes up to -2, and then I divide by the new power. And remember this time, because it's not a definite integral, you've got to have plus c. Okay, so I'll just talk through what I've done there. So first of all, x to the power of -1/2, I've increased that power by 1, so that will give you a half there. And then I'm dividing by the new power, which is a half, so I end up with x to the power of a half divided by a half, but the 2 remains at the front now. And the other one, I increase that power from -3 up to -2, divide by the new power, and I still have my 5 over 2 at the front. Now I've just got to tidy up. How many 2 divided by a half, how many halves go into 2 is 4. Another way of doing that is, if you don't like it doing it that way, is you just multiply the bottom by 2 and the top by 2, and you end up with 4x to the power of a half. And this one here, you've got 5 times x to the power of -2. You've got 2 times a -2 is going to give you -4. So I could write a -4 there, but instead what I'll do is I'll multiply that negative by this negative, or combine those 2 negatives, so that will give me a plus there. And then just to finish it off, to make it look all nice and neat, I can change the x to the power of a half as the root of x, and I can also pop this x to the minus, or to the -2 down onto the bottom, and end up with 4x squared plus c. Okay, so that's how you integrate a more complicated expression.